Thanks everyone for coming. You guys had a good day so far? It's been a long day, eh? Thanks for sticking with me. Thanks for making it all the way through to the last session. I'm acutely aware that I am the only thing that's stopping you from tucking into your first drink of the day, so I will try and keep it upbeat, try and keep it interesting. And today, we are going to talk about building a XAML app with MVVM. I love acronyms, use them all the time. If I use an acronym you don't know, shout out, I'll try and explain it. I'm Ian Randall. I have been a software developer since I can remember, really. Played with computers as a kid. I wrote out 10 print Ian, 20 go to 10 as a child, like most of us did, and from there fell into software as a profession. I've been doing it professionally since about 1997. I've done a little bit of this, a little bit of that, and for the last couple of years I've been fascinated with the presentation platform that's available on the Microsoft stack, specifically WPF. And when I say XAML today, for the most part of what I talk about, it's equally applicable for the web-based XAML you'll be using, so for your Silverlight apps, and more relevantly to the here and now, your Windows Phone 7 apps. But I'm a WPF developer, so I'll be showing you some WPF code. And when I say WPF, I mean XAML. You have to think and Silverlight. So I love acronyms. We're going to do the what, why, and how of the model view model pattern. So who here is a XAML developer? Who uses WPF or Silverlight? Good smattering. And of you guys, you use MVVM? Anybody not use MVVM, even though they call themselves a XAML developer? Okay, so half the room know what I should be saying, so I have to say the right stuff. The other half, believe me, it's true. XAML loves MVVM, and we're going to talk about why that's true. Did anybody see Ben Gracewood's Hard Hat versus Beret session just now? It was a real good session talking about, as a developer, you have a certain mentality toward hacking out code. As a designer, you have a certain mentality toward creating beautiful applications that encourage users to flow through. I'm a hard hat. I'm an absolute out-and-out noughts and ones guy. And the reason I love separation of concern so much is that I can actually give that beautiful, fluffy, woolly stuff to someone that's really good at that. I can completely dissect my view away from my code, and I can go and give it to someone to make it look awesome and work well. And I'm just going to talk a little bit about building these XAML apps with dependency injection as a kind of a theme. DI, to me, is a Nike technology, so just do it. We have debates in the teams I work with in terms of the added complexity and should we be doing this, and I have to go around smacking people and telling them, no, you have to do it this way. Before we so get into MVVM, I just want to talk about the evolution. So there are, in this building, hundreds of people that know more about MVC than me. Okay, so I'm not an expert in MVC. But in a nutshell, MVC turned up as a concept a long time ago in the Smalltalk community back in the 70s. A group of developers decided that they could actually put various bits of code that they were writing into various buckets that described what it was they were doing. And they introduced the concept of a model to describe the domain. And these are all terms that hopefully are familiar to us today, that the domain classes actually describe the business objects that we're writing, the customer class and the first name property on that customer class. These are all very old concepts. As I've put up there, so MVC is useful in stateless situations. For example, if you're pushing stuff over HTTP, you keep your application very stateless. So it's prevalent in web development. I've just sort of given you a few examples of MVC-based development frameworks, platforms. In the client space, it's impossible to talk about patterns without talking about Martin Fowler. Martin Fowler came up with the notion of the model view presenter paradigm. Again, there's going to be a heap of people that know more about MVP than I do, but in a nutshell, he came up with a presentation model where there was a couple of different flavors, the supervising controller, passive view. These are just Google terms for you to go and research if it holds an interest for you as to the subtle differences between them. But in a nutshell, a presenter would take control of what it needed to do, and it would actually give that piece of work to a view, and it would communicate to that view, and they would try and keep the presenter to view coupling loose by swapping in an interface to that view. So the presenter would have an interface to the view, and it would tell the interface, hey, go do something. Okay, so that's just a real lightweight example of that. A customer presenter there, you need to set the status on the view. You would actually create an interface to that customer view, and the interface would contain a method setStatus. Then any view you chose to layer across the top of your presenter must implement that setStatus method, and it would have view-specific code in it. Does that all make sense, everybody? Is everyone familiar with these patterns? This is just a bit of a background before we get into the real stuff. A few nods. Okay, so what does model view model mean? Where does it come from? So back in 2005, a chap called John Gossman, who was working on Microsoft team that were creating this brand new presentation stack, this brand new way of creating presentation applications, wrote a blog article about how they were using this the MVP pattern, but they decided that one or two of the bits in the XAML technology stack meant that they could subtly transform the presenter so that it would completely decouple itself away from the view. And all of a sudden it wasn't a presenter. We completely lost the interface to the iCustomer view is now gone. And this object that he created, he called it a view model. So MVP became MVVM. And the subtle difference between the presenter and the view model is that the view model has no knowledge of the view at all, not even with an interface. Okay, so what's a view model? Okay, so I'm standing here talking to you, and hopefully you're all listening and nodding and agreeing. But we as software developers, we're artists. We create beautiful code. It's elegant, it's performant, and we can look at it and go, the aesthetics of this code pleases me. Somebody else could come along and go, what a load of tripe. Well, I can't believe you've written it that badly. So if I'm standing up here saying, I believe, it's just an opinion, feel free to critique it as you would critique art. Feel free to disagree, to ask questions. I believe there are, at the core of the MVVM pattern, I believe there are three core concepts. I believe a view model should be an object that notifies anyone that's interested of changes to itself. Okay? So where the presenter would explicitly tell the view via the interface, go set the status, a view model should simply announce in a loud voice, my status has changed. Anyone that's interested in that change of status can come along and reflect and update accordingly. I believe MVVM should remove the need for unnecessary dependencies. Now, inevitably, there will be dependencies within your code. Things will depend on other things. We can minimize that with MVVM. And I believe a view model is something that allows us to exercise chunks of code in the way that as WinForms developers, as web forms developers, we would know as event handling. I believe that a view model should be allowing us to write methods so that we can actually support that running code in response to other things happening. And in the XAML space, that's called commanding. Okay, and we'll get into that. Okay, so why? Why would you use MVVM in the XAML paradigm? Now, again, it's just an opinion. I believe that most of the answer to that question is that the class called binding. So I'm just going to talk about what it is, what it does, and then I'll show you some code how it works in a little bit. But the WPF framework, the XAML framework, introduced a concept called a dependency object. And a dependency object is, I don't want to get too deep into it, but fundamentally it's something that is right at the bottom of an inheritance stack, which if you follow it all the way up the tree, there'll be things like framework elements, and above that there'll be things like user controls and windows and buttons. WPF has quite a deep inheritance stack, and I know that there's been sort of debate in the WPF community and the XAML community about composition over inheritance. Well, the reality is we have a strong inheritance model in the WPF stack. So deep at the bottom of this model is this thing called dependency object. And a dependency object effectively allows us to hardwire messages through a couple of layers of abstractions. We can kind of cut through some of the goo, some of the stuff that Windows needs to do to keep the UI responsive and keep all that going. We can actually slice straight through that and go into our controls and say, update, do it now. And it just makes our ability to keep the UIs responsive a little bit better. And it uses this concept called dependency property. So if you create a window and you add a text box, that text box will have a series of dependency properties. And they'll have, for example, the text property. Now what the binding class allows is we can create an instance of this binding class. And a binding it's a brand new object that sits in the framework, and it points to a couple of things. And the first thing it points to is back to that dependency property, back to that text in that text box. And it registers, I'm interested in that text box. And what we can then do is take a plain old CLR object, for example, the first name property being exposed off our customer object, and we can the binding class says, I'm going to come from over here. So whatever gets put into that first name on that customer object is going to find itself in the text of our text box. That's fundamentally how binding works. And when I first saw this, having come from a bit of a WinForms background, and I knew what binding was. Binding was when you dropped a data grid in, right? And you bound it to a source, and you could specify the columns, and I knew all about binding. And then Avalon came along, and WPF came along, and it had this brand new binding class that allowed us to bind anything to pretty much anything. And I was absolutely blown away with that. So again, we'll get into sort of how this works. I'll show you some code in a little bit. But fundamentally, binding is the magic answer to the question, why does MVVM work? It's the thing that allows us to shout out, hey, I've changed. Because the view itself, all it needs to do is create an instance of a binding class that's wired into this property. It notices that the property's changed, and it says, oh, that property's changed, I need to go back and get the new value and refresh myself. Is that all making sense? Okay, so commanding. XAML introduces the iCommand interface. And iCommand interface has a couple of things that we can use. It has an execute method, and it has a can execute method. The execute method, we can pass in an action, so we can pass in a delegate, we can pass in a chunk of code. We can say, here's the code I want to run when this command gets executed. And also, we can create a predicate. We can say, here's a condition that indicates whether or not we're going to allow that command to run. And again, I go back to my WinForms days, and the number of times I had to run some logic and run a piece of code and work out whether or not I actually wanted that button to be enabled. And then I'd go into my form, and I'd say button.enabled equals the result of that method. What have I done? I've taken a whole load of business rules and conditions and logic, and I've leaked it up into my view. So how would I then take that view and pass it off to a beret wearer and say, go make this beautiful? Because there's a strong dependency on the logic and the business rules, and I'm still working on that, and that could change. So with commanding, we can actually expose these as properties, and that allows the view to be completely disconnected from the view model. Now, commanding has hard limits. So by default, you can bind an object that implements the iCommand interface. You can bind it to something that has a command source property, something like a button or a radio button. These will have properties that you can set command equals and you can bind up. What you can't do by default is bind other events that you might want to raise. So if you're used to double-clicking a list box to get item changed, you can't bind that event to a command property. There are ways around it. So again, there are limits that as developers you need to be aware of. But commanding does solve a lot of that sort of issue of delegating methods and chunks off to the view model, separating it away from the view. So there's a bit of work there, and we need to think about those three core concepts. We need to notify the system of changes to our view model. We need to decouple our view models from each other so that they're not aware of each other with strong dependencies. We need to implement some sort of commanding implementation that allows us to put methods behind buttons. And it would be silly to rewrite that code again and again. There are some really clever people working in the Microsoft community, in the MVVM community, in the WPF community. So we might as well jump on their shoulders and use some code that they wrote, because it's probably going to be better than mine. I've just put a few examples up there. Look, there's a whole heap, and because it really isn't that big a deal. It really is just a couple of three core concepts. We could write our own. But I put a couple up there to show you that there are some options available. So, are people using these kinds of libraries in their MVVM work? The XAML developers? No, yeah, 1, 2. So there's a few. Okay. And the other guys, are you doing your own things? Are you raising your own property changed events? And hello? Thanks, Ivan. Okay, so Prism is not an MVVM library, but I put it up there because it's worth noting. It is Microsoft PnP practice and patterns. I love acronyms. I do. Microsoft PnP. Prism is composite application guidance. It helps you write composite applications, and it helps you separate those concerns out. It helps you write sort of view models or presenters, whichever technique you prefer. It helps you write views. It helps you bind them all together. It creates some of those helper methods for decoupling your view models or your presenters. One can write MVVM with Prism, but it isn't specifically an MVVM library. It's much more. Very clever chap called Rob Eisenberg wrote Caliburn, and it's been mentioned in some WinPhone 7 sessions. He's written a Caliburn Lite. Again, very popular. It does quite a lot of work for you. There's some real voodoo stuff going on, like auto binding of the view to the view model. You just kind of wave a magic wand over it, and it works out that this customer view needs to bind to this customer view model, and it puts it all together for you. It's some pretty clever stuff. The last two, MVVM Lite was written by a guy called Lauren Bunyan. It's a very popular library. I've never personally used it, so I can't comment on it. I know it's very popular. It's got all the core features we've talked about, but it's got a few more as well. So the code I'm going to show you today is I'm going to be using MVVM Foundation written by a guy called Josh Smith. Now, Josh Smith has an excellent getting started blog, and when I learnt WPF, I read his blog extensively. I wouldn't necessarily hold him up as being the most knowledgeable, the canonical source of MVVM, of WPF knowledge. But what I found was that he had a way of explaining complicated things really simply. So when I started, I read his blog fairly extensively. he was somebody that jumped on the MVVM bandwagon really, really early and said, hey guys, this is really good pattern, it really suits SAML development and we should all be looking at it. To the point where he's actually written a book, which it's a 52-page booklet. It's like $10 for the electronic version. It's really worth having a look if you're interested in the topic. AdvancedMVVM.com. Go have a look. So we're going to go through those three core concepts. So the first thing, it needs to publish changes. And XAML, so WPF gives us this iNotify property changed interface. Works in Silverlight as well and Phone 7 as well. And it's incredibly trivial. So I'm going to show you how it works. So this is Josh Smith's code. Can you all see that? Okay. So he wrote something called an observable object. The observable object actually implements this iNotify property change. Do I need to actually make that a bit bigger? There we go. How's that? A bit better? Too big? Okay. Okay, so here's the complicated iNotify property changed interface. It has an event. And that really is it. It just has an event. So when we create a view model and we tell it that the view model must implement iNotify property changed, all we're doing is putting an event on our class. Okay? So this is a base class, and we can let our view models inherit this base class. So the property changed event will go on to our view models, and we can raise those events via this base class. So how do we do that? Let me just show you. Okay, so he's put a little bit of debug code in. He's just verified that the name of the property that we're trying to raise the event for. So let's go back to our first name on the customer object. So we passed the word first name into here as a string, as property name. And he's just verifying that that genuinely is the name of a property on the object that's trying to raise the event. The next thing he does, he creates a handler to the property event. Now, I've seen lots of code that does it this way, and I've seen lots of code that does it the other way. The other way of doing this would simply to be say, if this.property change is not null, then this.property change and pass in this object. This is obviously the view model that we're interested in raising the event. Now the reason he would create a handler in this way is that in the event of having massively multi-threaded applications, potentially in the few clock cycles between us checking the property changed event and us invoking the property changed event, something else might have come in and killed it in the meantime. So convention is to actually create a local handler to that event, check the handler's not null, and if it's not null, then if something else comes in and kills the event, our handler is still valid and we can still raise that event. Okay? What we do is we create these property changed event args, we pass in the name, the string that we gave in the first instance, and then we just invoke the property changed event handler. And what this does, if you go back to our diagram with the binding class, the glue that sits in the middle of the dependency object and the POCO, it says, hey, that property has changed. It goes back to the dependency object. The dependency object goes, oh, changed. I must go get the new value. Goes into the POCO, reads the getter on that public property, and refreshes itself. And all of a sudden, the view has refreshed itself, and the view model still doesn't know anything about that view. Pretty cool? Well, I thought it was. Okay, so cleverer people than me have a little bit of an issue with this. Can anybody see an issue with this method of passing the names of properties into this event handler? Strings, right? So it's not very refactor proof. Okay, so I'm just going to do a little bit of coding. I did mention I was a hard hat, so we're going to go a little bit geeky on us, and we're going to show you another way of raising these property changed events using expression trees. So has anybody seen this before? Yep. 1 or 2? Okay, cool. So here's another way, and we're going to, I need to not lean down whilst I'm coding and talking. We're going to pass an expression that represents the property we're trying to change. And we're going to, from that expression, we're going to derive the name and we're going to pass that through to the event handler. Okay? It's going to look really, it's going to look something like this. So we'll override the raise property change method. We're going to make it a generic method, and the reason for that is we don't at this stage know what the type of the parameter or the property is going to be. Let's call that tprop. So that property we're going to raise the change event on, it could be an int, it could be a string. We don't know what it is yet, so we're going to make it a generic method, and we're going to pass in an expression that comes from the system.link.expressions namespace of func of tprop. Okay, so what does that mean? So expressions are a way of actually allowing us to gather up information and building up what they call expression trees. And what we're doing here is we're saying, I'm interested in some func of t. I want something that when I call, it's going to give me back an instance of t. In this case, it's going to instance of the type of the property that I'm interested in. So all we need to do is give it something that will yield a string in the if the Poco object type was a string. Is everyone following this? Yep. So if I give that a name, called that's the expression that's being passed in. Okay, so we can actually read this by getting into the expression. Let's just say we want to create a member expression. Now, a member expression is a kind of expression. It's a little bit nested. We haven't just given it the expression first off. We've kind of built it up out of in some way. So we're going to get hold of the expression. I could type. And we're going to say, get hold of the body of that expression and cast it as a member expression. It should be here. There it is. Okay, let's just do a quick sanity check to make sure that that's not null. If it's null, then we'll just get out of there. Just a demo. That's fine. And now what we're going to do is we're going to look at that member expression. So we now have a member expression. And for those of you who have dabbled into the system reflection namespace, a member would represent something like a method or a property. Okay? So we can actually get into this member expression, and we can say the prop info, let's just call p info, and we're going to look at the member expression we've just created. We're going to get hold of the member that's sitting in that member expression, and we're going to try and cast it as property info from the system reflection namespace. Now, this isn't using reflection. This is evaluating the expression tree at runtime to see what the name of that property was. So when you first see this, instinctively you think that it's using reflection, and instantly the alarm bells go, and it's all that slow, and it's going to grind my application to a halt. It's not. There have been people who have run studies. They've raised property change events with 1 million strings, and then they've done it with 1 million expressions, and the results are very comparable from a performance perspective. Okay, so we're going to look at that property info, and then all we're going to do is we'll just call through to the non-generic method here, and we'll just pass in the property info dot name. Okay, really I should have done that there and just check that pinfo wasn't null and throw in an exception. Okay. So how do we now call that? Well, let's go to some sample code. I'll just have a quick look at, I've got a view model in here. I have a username. Okay. So there's my username. I've got a private backing field. And in the setter, I'm doing a little sanity check. I'm saying, well, is the value that you're passing in, is it the same as what I already think this username is? Because if it is, nothing has changed, and I'm just going to get the hell out of here. If it isn't, we're going to carry on. I'm going to set my backing field to be the new value. So the backing field now becomes whatever it was that is being set. I'm going to dip into raise property changed on the base class. Okay, so let's not do this. Let's do this. And this time we're actually going to pass in an expression of func of t. Now this is where lambda's coming. So that would be really, really hard for me to create that expression. So I can just create a lambda that says no parameters. I'm just going to go to this dot username. And all I'm going to do is point at the property that I'm interested in. And it really is as simple as that. Hope that builds. Okay. We'll actually show you this code running in a little bit, but I thought it was worth showing you an alternative method of actually raising those property changed events. What we now have is hopefully a refactor proof, or at least a more solid, a more protected against refactoring method of raising those property changed events. Okay? So, yeah, so I'm not entirely sure. So the MVVM Foundation that I use doesn't. So I wrote that. Those 4 lines of code, I just wrote it. I have a version of MVVM Foundation that I use. So I just wrote it. Does anybody know? Do any of the others? I think Caliburn might. No one knows? That's right. And those 3-4 lines of code, you probably find them a dozen times in Stack Overflow. In fact, I think I answered it once. So no unnecessary dependencies. Okay, so a view model ideally is decoupled from the rest of the system. Yes, it's decoupled from the view, but we hope that it's also decoupled from everything else as well. If we're creating view models that need to know all about other view models, then there's code smells going on there. We can actually decouple the view models from each other using this mediator pattern. Mediator pattern is just a fancy way of saying pub sub. And what we do is we create an object called that works as like a hub, and it just sits in our application. And we can publish messages. We can say, hey, this happened, and that's it. Fire and forget. As a login view model, I publish the message that says, hey, this user's now logged in, and I'll pass a payload with that message. I'll give you the instance of the user object that I've just created because they successfully logged in. There you go, done. Now, as a login view model, I don't care what you do with that, Mr. Application. You do whatever you like. But the main window may well be sitting there ticking along, listening for those messages, and may well say, someone's logged in. I'm going to update my status bar along the bottom, and I'm going to get the name of the current logged in user, and I'm going to write it in the status bar. The login view model doesn't care about any of that. It's completely decoupled. So you don't have to have one subscriber. As many view models as you like in your application could be subscribed to the same message. At the same time as your main window is interested in this I've just logged in message, there could be all kinds of asynchronous processes that need to kick off. Now that we've got a logged in user, we want to go hit the database, we want to go and get your user permissions, so which bit of this application can we use? So now that this I've logged in message has fired, those things can get kicked off and they can get started. Okay, so how does that work? It's actually okay. So I actually created the base foundation didn't come with an interface, but I interfaced it out because I wanted to test it. Oh, testing! MVVM is all about testing. I don't know. The iMessenger interface really isn't that hard. So basically, we're just going to register for certain messages, and we're going to notify that certain messages are occurring, certain things are happening, and we can pass parameters, we can pass payloads with those messages. Again, I took this, and personally, I created one that had a message-based class, and I create message objects that are strongly typed and inherit that message base class, and I pass them around as strongly typed. It just gives me that little degree of sense that I'm not got magic strings littered through my application. But strings is fine for showing you how it all works. So I'm sure you could all imagine what this does. But really the only really interesting thing in the implementation of this mediator pattern is the fact that he uses something called weak references. And a weak reference basically will create a reference to the callback. So fundamentally we're building callbacks, right? We're building up chunks of actions. This is work I want you to do when this message happens. And we're storing those delegates, storing those callbacks as weak references, so that if at some point in the future something else comes along and destroys that view model, then we can, when we try and access it, it's just going to quietly go, yeah, that view model's dead. It doesn't need to run that code anymore. And it'll just dispose it quietly and go away, and our application won't start leaking memory. But otherwise, it's pretty much what you'd think it would do. So if I go to the login handler here, so I've injected an interface to a login service up in here. That interface to the login service is going to provide me with my methods, my login method. It's going to provide me with the domain object, the user object for the current logged in user. Just as a little side note, I'll show you the implementation of the login service because I think you'll like it. There you go. If username's Ian and password's 123, then we're sweet. In the real world, of course, your login service would implement this login method, and you'd send it off to some repository, and you'd send it off to some database or something to say, here are the credentials, please validate them, please come back with a result. Okay? So that login service gets, the login message gets invoked, pass in the credentials, I get a result back, and assuming all is well, because I haven't failed and I haven't bombed out at this stage, I'm actually going to notify the application we've logged in. Simple as that. Does that all make sense? I'm out of time. Okay. So commanding, and I just the login handler that I just showed you, I'm going to dip back into it again in a minute because it's an example of a piece of work that's been thrown at a command as an action to perform when the command gets invoked. We've already talked about the iCommand interface. We've got the execute method and the can execute predicate that's going to return a Boolean, a condition, and whether or not we're going to allow you to do this work. And what's really neat with the iCommand interface, when you bind it up to something like a button in WPF, is that if this can execute predicate returns false, then the button will just grey out for you. You won't be able to click it, and you don't need to write that plumbing code. You don't need to go back in and go button.disabled equals true, or whatever the syntax was. I can't remember. So commanding. Just go back into my constructor, and I have a login command here. Let me just quickly show you what that is. It's just an iCommand. iCommand comes out of the system Windows input namespace. Okay? Defines a command. Useful. Okay. So go back to where we were. So the implementation here, again, it comes out of Josh Smith's MVVM Foundation, but all these helper libraries will have them. You could easily roll your own. It's an implementation of the iCommand interface. It's a class that allows you to expose those execute methods, can execute predicates. Okay? And all I've done is I've passed in a login handler, which is a void method that takes no parameters. Can login. It's a bool method that takes no parameters. Now there's a generic implementation of relay of command. So you can go relay command of t, where you pass in a t to both the execute and the execute methods. You pass in an instance of t, and it'll use those as parameters to help it make its decision as to whether it's going to allow you to do it or what it's going to do with the work. So there are generic implementations of that. But that's, and essentially, that's how commanding works. And the way that we would actually let our view know that this command needs to be run is that we go all the way back to our magic, the answer to the question, which is binding. So we go into our view. Let me find my button. And it really is as simple as setting the command on the button and using a binding to specify the path through to the login command. Remember that the login command is simply being exposed as a public property on the view model. Okay. Let me go back into the code. So is that making sense to everybody? Okay. So here's my login app, and here's all the bits and pieces. Here's all the bits and pieces hanging together. What I've got here is a very simple login screen. It's got a login name, password, and my button. My button is disabled. Can't hit it. I can type in something here. I can type in some password here. This is going to fail because the username isn't Ian and the password isn't 123. All of a sudden my login button is now available. And as I hit it, I go back to my service. It fails. It sets the login result to be something. That login result goes, I failed. And the view says, interestingly, this login has just failed. I must go to the property getter of the login result property, and I must get the new value. And then all I do is bind the new value of login.failed to the visibility of that message. And the way we do that is by using a custom converter, a value converter. Okay? Now, a value converter should be in my thing. So, login result to visibility converter. Login result is just an enum, so it's going to be either not, I haven't tried yet, or I've passed or I've failed. So, a value converter is an object that implements the iValueConverter interface. You have a couple of methods you need to implement with that interface. That would be convert and convert back. Now, since we will never take the visibility of that message and convert it back into a login result, we don't need to implement that convert back. And quite often you'll see convert back will just throw a new not implemented exception because that isn't the way that converters are typically used. But they can be. For things where you want to enter stuff in the user interface and you want to convert them back into objects, you'd put that there. So the implementation here is pretty simple. Take the login result. If it's failed, then hey, show that message. Make it visible. Tell the world this has now failed. Okay? And the way that we, what was I going to say? The way that we go, yes, so here. So we actually bind, excuse me, I think I'm here. Okay, so we actually bind to that login result, and then we can just pass an instance of the converter as a parameter of the binding. And that's what's really cool about binding is that you can say, yes, I want you to bind this bit over here to this bit over here, but there's all these extra little things you can do. Like you can say, along the way, turn it from being a login result, which is just an enum, to a visibility, which is another enum, coincidentally. And just as one last little pro tip, a when I say that Josh Smith is an easy guy to read to get started, when you read a little bit more, it's worth reading a guy called Dr. WPF, who I find his blog reasonably advanced. Not great to get started with, but when you get deeper into it, he's the guy that the Josh Smiths and the Lauren Bundens of the world turn to when they run out of ideas. He's really, really smart. And he published a little tip that said in your converters, if you make your converter inherit markup extension, then you can actually create this override, this provide value method, and you can actually in the markup you can say when you're creating your XAML, here use this object. Because that's all XAML is, right? XAML is declarative creation of objects. When we go angle bracket button, we're effectively writing button B equals new button. That's all we're doing. We're creating new objects. Because it's an XML syntax, because it's an angle bracket syntax, you can't just keep putting angle brackets in and the parser gets all confused. So we've got this thing called markup extensions that allow us to use those curly braces that you saw in the binding syntax. And we can create our own markup extensions. So when you say text equals curly brace binding path equals blah, the curly brace means, hey, go create me a new instance of a binding class, please. And we can say, go create me a new instance of a login result to visibility converter, please, because this is a markup extension and we've overridden the provide value. And I'm just using this beautiful little helper class that came in .NET 4 called Lazy of T, which is my favorite .NET class, to lazily load and provide a singleton instance of that converter. For sure. So for usage, we now have in our login example.infrastructure namespace, we have a login result to visibility converter class. Okay, so flicking back to the XAML, we declare our namespace here. So we go XML ns colon whatever the name is. In this case, it's infra to represent the infrastructure namespace. And we've pointed it to the login example.infrastructure namespace. We can now use that namespace in our XAML. And the converter, if I can find it again. So all we're doing is squirrely brace, which means please create me a new infra, which is our infrastructure namespace, login result to visibility converter. So its usage, it makes it really, really simple. The benefit of doing this is that the typical way of putting converters in is to actually take that infra namespace and create a resource, and you give it a resource key, and it's probably going to be something long and complicated, and then you go into the converter, into the binding, and you say path equals login result, converter equals, and then you have to point it to a static resource, and then you have to give that key to the static resource. But Lazy of T is my favorite class because I am lazy. This is much, much easier, and I prefer it. So I'm going to wrap it up a little bit early because, you know, it's 6:15 and we're probably all thirsty. We've got 5 or 10 minutes. Does anybody have any questions at all? Is there anything that you were expecting to see? Yep.
Do you have a website for that Dr. WPF?
Yeah, so just drwpf.com. Go straight through to his blog. drwpf. 10 minutes left. Excellent question. The model. The question is, why do MVVM demos never have a model in? The answer to this is because I uploaded the wrong version of my PowerPoint. So, imagine there's a slide that says, but what about the model? So what I want to do is just talk through an example of how I personally, again, this is just opinions, how I personally would use a model. I'm not constrained to the thing anymore because I'm not pressing computers. Oh, there you are. Awesome. So if I were creating a new page in my brand new application and I've logged in, you can't see me down there, can you? back in the headlights. I'd do it something like this. I'll go back to my artistic opinion, just opinion, you're free to disagree. The user presses a button that says change password, so I know who the user is. Okay? What I want to do is create a new instance of that domain, that model object, that user model object. So at a domain level, my user class would expose a username property. It would probably contain a password property. And then I'd go running off to the business and I'd say, at a business level, what must your password conform to? What rules must it have? And they'd say, oh, it's got to be 10 characters long. And you'd go, right, if password.length is less than 10, then failed. Anything else? Oh, yeah, it's got to have alphanumeric. Right, alphanumeric. You'd code it in. And it lives in the domain. It lives in the user object, the model object. So now I want to expose this to my users to say, you want to create a new password. Well, that's cool. So what I want you to do is type in your old password, first of all, and I'm going to verify it against you are who I think you are. Then I'm going to expose another couple of text boxes, and it's going to be, please enter your new password. Please confirm your new password. So my view model is going to expose a couple of properties called attempt 1 and attempt 2. And I'm going to build a rule in my view model that says attempt 1 must equal attempt 2. Now that's a view concern. I'm only concerned now that you're typing your new credentials in. At this point in time, I now care that you typed it in properly and that attempt 1 equals attempt 2. I'm not going to store this in the domain. I don't care what your first attempt was or second attempt was. So my domain model will run those validation rules. Hey, I may choose, up at the view model, I may choose to resurface those client validations because it may be more performant to actually trap it up on the client before I send it off to the server. But either way, the view model is going to do its thing. It's going to validate that the first attempt is the same as the second. It's going to pass those credentials when it's happy that it's okay. It's going to pass them through to the domain, and it's going to say, here's the new password, and the domain's then going to do its thing, and it's going to run its domain level validations before committing off to some repository. That's how I'd do it. If you want it to. If you implement iNotify, so the question was, does the model need to implement iNotify properly changed as well? So if the model implements iNotify properly changed, you have to ask yourself, is it still a model? And if the honest answer is, well, yes, it is, it's just I don't want to create another layer. I don't want to create a view model because all I'm doing is chucking it on the screen, binding to it, but I know that something else might come in and change something, and I want to see those changes reflected. Yep. Perfectly valid to do that. Again, it's a design choice, and I don't have the answers, I just have opinions. As a rule of thumb, so I was doing this recently, and I was creating something for a load of payments. So I had to go to some data store, and I had to go and get a load of payments, and I had to list them out. There were fees that were due, and list out the load of the fees that were due. The fee was a domain object. It lived in my domain. It had an amount. It had a due date. It had it linked to a contact. So in the context of that contact, I brought up all his unpaid fees, and I gave the user the opportunity to pick the fees they wanted to pay. So in my view model, I exposed a Boolean property that said, is selected. Are you choosing to pay this fee today? And I also exposed an instance of a fee object, which is a domain object. And the reason I didn't go in and look at that fee object and look at the due date and the name, and I didn't create all those properties and raise the property changed events is because that fee was read-only in that instance. And I didn't need to raise any property changed events. I wasn't changing anything. It was read-only. I was just looking at that fee and picking a button to say, yeah, I want to pay you. So as a rule of thumb, I would say if you're not changing it, use a domain object, put it onto your view model, expose it that way. if you're probably going to be changing it and manipulating it and working with it before you want to commit it back to the domain, then you probably want to create a property that represents the corresponding property down on your model object. Yeah?
The MVVM programmers seem to be quite Nazi-like, where route viewing command comes into it, and it's kind of like we must always blind to our commands, no route viewing command.
Yep.
Is there a happy medium? I often find that you have a lot of different parts of your model that need to respond to the same command. You might have multiple view models, and if you've just got a command on each one, you might want to handle it globally.
Okay, so the question is, how do I summarize that?
You tell me, and I'll probably know it better.
So the question is, when you're exposing routed UI commands, you have many view models that,
Well, you might have many forms,
right?
each doing a specific task, but you might have something.
Okay. Okay, so lots and lots of things all pointing to the same model. That model is exposing commands. Again, it's opinions. I think if you have a view over here that's doing a certain job, and yes, it's related to this domain model, personally, I would probably create a view model for that view, and I probably wouldn't reuse it. And I would say that the command would be a property of that view model, and you could tailor it specifically for what you wanted that view to do. That's what I would do. And you may end up writing a bit more code, and you may end up thanking yourself later for later. We're wrapping up, and people are drifting. Is there anything else? Oh, so what are my opinions on no code behind on the view? Yeah, so code behind in the view is absolutely fine, and I use code behind in my views, and I use the code in my views builds my views, and that's all it does. But what no code behind in the view means is don't leak your business rules into your code, because at that point you can't slice the XAML off and give it to a developer to work in, a designer to work in Blend. Keep your business rules in your view models. That's what it means as a guideline. Yeah, if you see code and code behind, it's a warning bell, but as long as that code is view-centric, hey, you're fine. Again, that's just an opinion, and somebody else could stone me for it. I don't know. Okay, let's wrap it up, guys. Thanks for listening. Really, really appreciate it.